Okay, this is a circle measure using radians question. You get given the logo for a company that makes chocolate is a sector of a circle with radius 2. That's the radius there. The area of the logo is 3 pi. Find this angle here, theta. That's what we've been asked to do. So, we're going to use, we have a formula for the area of a sector in radians. You can read it off from the formula booklet. It's theta over 2 times pi r squared, which in this case is 3 pi. And we know r is 2. So we get theta over 2 pi times 4 is 3 pi. You can divide both sides by pi. Let's get rid of those. 4 over 2 is 2. So theta ends up being, so we've got 2 theta is 3. So theta is 3 over 2 radians. Find the total length of the perimeter of the logo. Well, the perimeter of the logo is made up of this arc length, big arc length, plus these two sections here. So the perimeter is given by, and again we have a formula for arc length, plus the two sections of the perimeter of the radius, two radii, 4. Arc length, the formula is just theta times r plus 4, which is 3 halves of 2 plus 4 is 7. A mathematics test is given to a class of 20 students. One scores 0, but all the others score 10. This question is about mean, medians, and really most of this you should be able to answer as a GCSE student, so these are 5 straightforward marks. Find the mean score for the class. Well, you've got 20 students, 19 of them scored 10, plus 1 that scored 0, for a total of 190 marks in the whole class. To find the mean, you do the total, divided by the number of pieces of data, which in this case is 20. Do that division, 19 over 2 is 9.5 marks each. Part B, write down the median score. Well, the median score is just the number in the middle, so it should be fairly obvious, since nearly all of them are 10, that wherever the middle is, it's going to be 10. So that's why it says write down. Don't have to do any calculation for part B. You can just write down that it's 10. And part C, write down. So again, you shouldn't need to do any calculation. Write down the number who scored above the mean score. Well, the mean was 9.5. How many students got above that? 19 got above the mean. What about below the median? Well, the median was 10. And there was 1 student below the mean, 1 person who got 0. Sorry, below the median. Easy marks. Find the integral of 1 plus tan squared x with respect to x. 2 marks. It's 2 marks because you're expected to spot that 1 plus tan squared x is the same thing as sec squared x. So in order to do this integral, you're really just integrating sec squared x with respect to x, and sec squared, again, you can just read it off the formula sheet, because we know that tan differentiates to sec squared. So part A, straightforward. Part B, find the integral of sine squared x. A little bit more involved, but we've done this so many times, you should know that for sine squared x and cos squared x, in both cases you use one of the cos 2x formulae. There's a version of the cos 2x formula that exclusively uses cos squared, and there's a version that exclusively uses sine squared. Don't need to have them memorized. And then you take that formula, rearrange it for sine squared. It's 1 minus cos 2x over 2. And instead of integrating sine squared with respect to x, we can integrate that with respect to x. It might be easier to think of it as integrating half minus cos 2x over 2 with respect to x, which integrates to x over 2 minus cos integrates to sine, because it's 2x, we divide by 2 when we integrate, so that's plus, including this divide by 2, and the one from integrating we get a divide by 4, and don't forget the constant of integration. I'll squeeze in down there. This question is all about differentiation from first principles. It walks you through it though. Part A, saying expand x plus h cubed. So if we do that, we can just use the binomial theorem. Obviously the first term is x cubed, the last term is h cubed. We've got x squared, h must be this one, and xh squared, without space. Let's work a little bit smaller. First term is x cubed, last term is h cubed, and in between, the next term will be 3, choose 1, x squared h, 3, choose 2, x h squared, but there's a good chance that you have those memorized anyway. You can always draw the triangle if you need to, Pascal's triangle, to give you that answer. Part B, hence find the derivative of f of x is x cubed from first principles. You need to recall the fact that the definition of differentiation is the limit as f tends to 0 of f of h tends to 0 of f of x plus h minus f of h all over h. In this case, we're using f is x cubed, so it's the limit as h tends to 0 of x plus h cubed minus, for Pete's sake, shouldn't be, there should be an x here, shouldn't it? Minus x cubed all over h. Now obviously we've already done that expansion in part A, so this is the limit as h tends to 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h. And this all simplifies because you've got an x cubed here and a minus x cubed here that add up to make 0. And once they're gone, let's obliterate them a little bit more comprehensively. You can do the division because everything else has a factor of h, so you can divide by h, and you'll be left with 3x squared plus 3xh plus h squared. And we can take the limit as that goes to 0, because the limit as h tends to 0 of 3x squared doesn't have anything to do with h, plus 3xh, well, that goes to 0, plus h squared, well, that also goes to 0, meaning that our answer, as you would expect, is 3x squared. Functions f and g are defined like that. This question is all about even and odd functions. So we'll start with f of x is an even function, which means that f of x is equal to f of minus x. Ax squared plus bx plus c. F of x is ax squared plus bx plus c. Let's do this in a different colour. That's f of x. What about f of minus x? Well, that's a of minus x squared plus b times minus x plus c. And that gives us ax squared minus bx plus c. And since a lot of these are the same on both sides, we can subtract ax squared from both sides, subtract c from both sides, and we're left with bx equals negative bx. And if you can't see from there that b is supposed to be 2, you can add bx to both sides. And you get 2bx is equal to 0, which means that b is 0. Part B, given that g is an odd function, find the value of r. P sine x plus qx plus r. So if it's odd, that means g of minus x is equal to negative g of x. That's what an odd function is. And g of x, just for reference, because it's got squished up the top there, is p sine x plus qx plus r. So g of negative x becomes p of sine negative x minus qx plus r. And obviously negative gx just means negating everything, minus p sine x minus qx minus r. Again, some of these terms will vanish. Q minus qx appears on both sides, so that has no bearing. And p sine minus x is the same because sine itself is odd. You can write minus p sine x. That's sine x minus sine x, and the sine of minus x are the same because sine is an odd function. And that means that you have a minus p sine x appearing on both sides. And we end up with r is equal to negative r, which is the same thing as we had just a moment ago, essentially. 2r is 0, so r is 0. Part C tells you that h of x is both odd and even, which means that h of x is equal to h of negative x. That's right, I'm going to write that in a different order actually. Means h of negative x, because it's even, is equal to h of x, and because it's odd, is equal to minus h of x. can just look at this expression, this equality, and it's the same thing we've seen in the previous two parts. We've got something is equal to negative something. You can add h to both sides, and you get 2 lots of h of x is 0, which means that h of x is 0. The only function that is both odd and even. Function f is defined by f of x equals 3x minus 2 over 2x minus 1, where x is not a half. Find an expression for f minus 1. First thing is, that means the inverse function. We're not differentiating here. So, the way we usually do inverse functions is we write y in terms of x, and then we rearrange to make x the subject. So by multiplying both sides by 2x minus 1, you get 2xy minus y equals 3x minus 2. And then I'm going to collect the x's together on one side and the y's together on the other. Well, anything not involving an x on the other, and make x the subject. So I'm going to subtract 3x from both sides, and I'm going to add y to both sides, so I end up with 2xy minus 3x equals y minus 2. Nearly done. Take x out as a factor here, and you get 2y minus 3 equals y minus 2. So we get x equal to y minus 2 over 2y minus 3, which means that f inverse of x, we're going to swap around the x's and the y's, because we refer to everything in terms of x. And we will ask for f inverse of x. So there is f inverse of x. Run out of space there, so I'm going to do part B here. On a clean one. Given that f of x can be written in that form, there's f of x. A plus b over 2x minus 1, find the values of the constants a and b. So basically we're solving this problem. A plus b over 2x minus 1 is equal to 3x minus 2 over 2x minus 1. And in order to solve this, it makes sense to write that all over a common denominator. That's a times 2x minus 1 plus b over 2x minus 1 is equal to 3x minus 2 over 2x minus 1. And in fact, now that we've done that, we can ignore these denominators and just think about the numerator, because if the denominators are equivalent, then the numerators must have to be equivalent. And we're solving this equation that we've got on the top. There's a couple of ways to do it. Probably the easiest way, because this equation has to be true for all values of x, you can pick a value of x substitute it in and get your equality that way. Why did I pick x as a half? Well, I picked x as a half because that's going to make that bracket 0. So that will give me b is equal to 3 times a half, so 3 halves minus 2, which is negative 1 half. So that's b. And then I can choose a different value of x. Let's choose 0. So that makes life easy as well. And that gives me minus a plus b is equal to negative 2 from this side here when x is 0. And we know what b is. b is negative a half. So that must mean that negative a is equal to minus 2 plus a half, which is minus 3 halves. So a is 3 halves. And part C says, hence write down the integral of f of x. Well, we've done all the hard work because we're integrating. Instead of integrating the function, we're going to integrate the function. Oops, we're going to integrate the function that. And we know what a and b are, we've just worked them out. A is 3 halves, b is minus a half. So we can do this integration because a, 3 halves, integrates to 3 halves of x. And this bit here integrates to b, well that's minus a half of log mod 2x minus 1 plus c. Done. This question is about polynomials. We've got a polynomial there, p of x. For the equation p of x equals 0, state the sum of the roots and the product of the roots. This is all about, well, the sum of the roots, alpha plus beta plus gamma. We've seen this, a, I. Sum of the roots is given by minus b over a, which in this case, where a, b, c, d, e, f are the coefficients, 2, 1, minus 26, minus 13, 72, and 36. So that's minus b over a, so that's minus 1 over 2, minus a half. And the product of the roots, same thing, a little bit more involved because you have to think about the sign, but it goes negative, positive, negative, positive, negative, 36 over 2 again, so that's minus 18. A new polynomial is defined by q of x equals p of x plus 4. Find the sum of the roots of the equation q of x equals 0. This question, it's best to think of p of x plus 4, qx, is what effect does that have on the roots? And think of it as a graph. Well, this is a translation in the x direction of negative 4. Oops. Which means that all the roots have 4 taken away from them. It's a quintic. It's a polynomial of order 5, so there's 5 roots. Each one has 4 subtracted from it, for a total of subtracting 20 from the old sum. And the old sum, just to remind you, was minus a half. So that's minus a half minus 20 is minus 41 over 2. This one's a good one. I like this one. Question 8. By using the substitution given, find that integral. So the first thing to do is to apply this substitution. Don't forget to differentiate. So du by dx is e to the x, which means that dx can be represented as du over e to the x. Doing that step first allows you to see that doing this substitution is going to give you some cancelling. So I'm going to do that first. E to the x over e to the 2x plus 6e to the x plus 13 du over e to the x. And we've got to multiply and divide by e to the x, so those cancel out. The other thing you need to do is to spot that this is a quadratic in e to the x, and probably it factorises. No, not factorises. You can complete the square. And if you complete the square, something handy will happen. And this is why they've picked e to the x plus 3. If you complete the square, you get e to the x plus 3 squared. That gives you your e to the 2x from e to the x squared plus 2 lots of 3e to the x. It also gives you a 9 that you don't want. There's a 9 we don't want. We want the 13, so that's plus 4. Finishing the substitution, we're replacing e to the x plus 3 squared with u squared plus 4. And this one is one of the standard ones that we've seen. X squared plus 4, or x squared plus 1 usually, integrates to arctan of u over 2 plus c. Functions f and g are defined. Show that g of f of x, there's a nice easy mark this late in the game. G of f of x. Well, g of x is 3 sine x. So all you've got to do is be a bit careful about your communication, because if they didn't give you the answer, you'd probably just write this down. G of f of x is 3 sine f of x plus 4, which is 3 sine 2x plus pi by 5 plus 4. Find the range of g of f of x. So the range of g of f of x is, well, this bit, in fact, maybe not even that bit. But what about, without the 3 even, sine, this sine function, underlined in purple, that goes between -1 and 1, which means this 3 sine function goes between -3 and 3, we're obviously inclusive. So when you add the 4 on to a function that goes between -3 and 3, then g of f of x must lie between -3 add 4, which is 1, and 3 add 4, which is 7. Part C, given that g of f of x, g of f of 3 pi over 27, find the next value of x greater than 3 pi by 2 for which g of f of x equals 7. So there's a bit of a clue here. 7 is the maximum. We know it's some sort of sinusoidal function. So if we've got a point here, 7, all we have to think about is, well, what's the period of this function? Now, usually the period of sine is 2 pi. However, there's a transformation on it here. The 2x means that the period will halve, not double, but halve. So this point, the next point where we get to the maximum, won't be 2 pi away, it will be pi away. So we can conclude that if g of f of 3 pi over 20 is 7, and if we add pi to that, g of f of 3 pi plus over 20 plus pi must also be 7. And 3 pi over 20 plus pi is 23 pi over pi. 23 pi over 20. part D was state the 4 transformations that can be applied to the graph. Now you can apply them in slightly different orders, but it's probably easiest to stick to good old BIDMAS. Deal with the things in the bracket first, and then deal with the things outside the bracket first. Deal with the divisions and the multiplications before you deal with the additions and the subtractions, which means that the first thing we should consider, I'm going to write it out again. First thing we should consider is 3 sine 2 pi plus 2x plus pi by 5. Well, following the order of BIDMAS, the first thing we should consider is inside the brackets, the 2x. What does that do? Well, I've already mentioned what that does. It's a stretch in the x direction, scale factor a half. Then we'll do the addition and the subtraction in the brackets, which is a translation in the x direction of minus pi by 5. It's gone to the left. Then the 3 here represents a stretch in the y direction, scale factor 3, and then lastly, it's gone off the top of the oh no, I've forgotten to write it down, the plus 4 that was in the equation before. So lastly, the plus 4, which is a translation in the y direction of 4. If you do these things in a different order to that, then some of the numbers will change. So if you've done things in a different order, maybe you can get a different correct answer, but it probably makes most sense to do them in that order and apply the order of operations that we're familiar with. Right, the last question in section A. A team Melchester Rovers. You may have noticed Melchester Rovers have appeared before in IB questions. I think it's, I don't know, probably some sort of inside joke. The probabilities that win, draw or lose a match are half, 1/6, 1/3. The probabilities remain constant, which makes you wonder what their coach Roy is doing. But he loses his job if they lose 3 consecutive matches, otherwise he does not lose his job. Find the probability that Roy loses his job. First thing to realise is that you only need to think about losses and not losses. Losses, the probability of a loss, we're told, is 1/3, and therefore you can work out the probability of not a loss is 2/3. And the other numbers, the half and the 6th, don't have any bearing on the question. He loses his job, so they've got 5 matches. He loses his job if they lose 3 in a row. So, how could that happen? Well, if they lose all 5, then he's obviously lost 3 in a row. So the probability that loses all 5 is 1/3 to the 5. Or 1/243. Non-calculator paper. It's not a nice number, really. If they lose 4, then that wouldn't necessarily be 3 in a row, will it? Because they could lose, lose, win, lose, lose. So let's look at how many lose 4 combinations there are. There's lose, 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 win. Lose, lose, win, lose, lose. No, that one doesn't count. So let's try and be a bit more systematic. Lose, 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 win, lose. 2 losses with a win in the middle and then 2 losses wouldn't count. So just flip these round. That's the others. So there's 4 ways. If he loses 4 different ways, that would lose him his job. So that's 4 times, well, what's the probability of him losing? 4. 1 over 3 to the 4. Third times third times third times third times 1 win, which is 2/3. So altogether, that's still out of 243. But that's what, 8 out of 243. And then the 3 losses. I think maybe we want to be a little bit cleverer when we're thinking about the 3 losses. So if he only has 3 losses, then he can either win. The only way he'd lose his job is if he won, followed by 3 losses. So if he only had 3, then they've got to be in a row, right? So any of those combinations, win, win, followed by 3 losses, a win, 3 losses, then a win, or 3 losses, followed by 2 wins, and they've all got the same probability, so that's 3 times 3 losses, which is 1 over 3 cubed, and 2 wins, 2/3 squared, for a total of 12 out of 243, and if you add all that up, it's going to give you 21 out of 243. Seems pretty good odds to me. Less than 10% chance in the volatile world of Premiership football. And that's the end of Section A.